A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. I was playing around with a custom Telegram bot the other day, just a simple interface for some research tasks, and I realized about 20 minutes in that the model was still trying to format its answers based on a joke I made at the very start of the session. It was like talking to someone who refuses to let a topic drop, even though we've moved from talking about pizza toppings to discussing deep-sea thermal vents.
That is the classic context pollution trap. It's funny you mention that, because today's prompt from Daniel is about exactly that, the engineering challenges of session management in AI front ends. Specifically, how do we handle the fact that AI APIs are stateless while human conversation is deeply stateful, especially in interfaces like Telegram or voice assistants where you don't have that big shiny new chat button to bail you out?
It's the invisible baggage of AI. We think we're starting fresh, but the API is just seeing one massive, growing blob of text. By the way, listeners, if we sound extra sharp today, it might be because Google Gemini 3 Flash is writing our script. We're living the high life, but back to the baggage. Herman Pubbleberry, why is it that in April of 2026, we're still struggling to tell a machine, hey, that was then, this is now?
It's a fundamental mismatch between how we communicate and how these models process data. When you use an API from Anthropic or OpenAI, every time you send a message, you aren't just sending that one message. You're sending the entire history back to the server. The model doesn't remember you from 5 minutes ago unless the developer explicitly bundles that history and shoves it back into the context window. The problem is that once that window gets crowded, even with the huge 128,000 token limits we have now, the model starts to lose the thread. It's called the lost in the middle phenomenon, or more simply, context pollution.
So, if I don't have a new chat button, the model eventually just becomes a confused mess of every random thought I've had in the last hour. If I'm building a bot on a platform that isn't a dedicated chat UI, how do I stop the model from drowning in its own memory?
That's the core of Daniel's question. We have to engineer session boundaries where they don't naturally exist. If you're building a Telegram bot, the user expects a continuous stream. But for the AI, that's a nightmare. The first tool in the shed is deterministic session management. This is where the front end, the code sitting between the user and the AI, imposes a hard limit. You could do this with a simple timeout. If the user hasn't messaged in 30 minutes, the next message they send is treated as the start of a brand new array of messages. The old context is archived, and the model sees a clean slate.
A 30-minute timeout feels a bit like a conversational guillotine, though. What if I was just really slow at typing my next deep-sea vent fact? Is there a way to do this that feels less like I'm being hung up on?
You can get more surgical with it. Instead of just a timer, you can use command triggers. Most Telegram bots use the /start or /reset commands. It's a bit clunky because it requires the user to know the command, but it's deterministic. It's a hard reset. But the real engineering magic happens when you start using metadata and system prompts to simulate state. Instead of just dumping the whole history, you could have a separate process, maybe a smaller, cheaper model. Summarize the key points of the previous session. You insert that summary into the system prompt of the new session. That way, the model knows who you are and what you were doing, but it isn't distracted by the literal word-for-word transcript of your bad jokes from 10 minutes ago.
So it's like a briefing note. The model gets a memo saying, Corn is a sloth, he likes thermal vents, don't bring up the pizza thing again. But that still requires me, the developer, to decide when that memo gets written. Daniel mentioned autonomous session management. Is that where we're heading? Where the AI itself says, okay, We're done with this topic. Let's flip the page.
We're seeing the early stages of that with frameworks like LangGraph and Crew AI. These are agentic frameworks that don't just follow a straight line, they have loops and decision nodes. An agent can be programmed to evaluate the drift of a conversation. If the user shifts from talking about Python code to asking for travel advice in Jerusalem, the agent can trigger a state change. It can effectively spawn a new session and move relevant variables over while dropping the irrelevant code context. It's much more expensive in terms of compute and latency because the model is constantly meta-analyzing the conversation, but it solves the pollution problem.
It's like having a very polite moderator in the room who occasionally clears the whiteboard when it gets too messy. But let's talk about the cost of that mess. If I'm a developer and I'm just letting the context window bloat because I'm lazy with session management, what's the damage? Is it just that the AI gets a bit loopy? Or am I actually burning money?
You are absolutely burning money. In 2026, we talk a lot about token costs, and while they've dropped significantly, they aren't zero. If every message you send includes 10,000 tokens of history that aren't needed, you're paying for those 10,000 tokens every single time you hit enter. It scales exponentially. But beyond the wallet, there's the quality of the output. When the context window is polluted, the model's attention mechanism gets diluted. It starts giving equal weight to a typo you made 20 messages ago and the complex instruction you just gave it. That's where you get those weird hallucinations where the AI insists on sticking to a format or a persona that is no longer relevant.
I've seen that. You ask for a summary, and it gives it to you in the pirate voice you asked for 3 hours ago, as a joke. It's funny for a second, then it's just annoying. So, if we look at something like a voice agent, which Daniel mentioned as a place where you definitely don't have a button, how do you handle the end of a session there? You can't exactly ask the user to say /reset mid-sentence.
Voice is the ultimate challenge for session management. Silence detection is the most common deterministic trigger. If there's a gap of, say, 60 seconds, the session closes. But there's a more sophisticated way using intent classification. You could have a very fast, local model something running on the edge that just looks for transition phrases. Things like, okay, thanks for that, or actually, let's switch gears. Those phrases act as soft triggers for the backend to consider this segment of the conversation closed. We're moving toward a world where the context window isn't just a sliding window that forgets the oldest stuff, it's a managed memory space.
This reminds me of when we talked about not hard-coding usernames in prompts back in episode 1811. It's the same principle of persistent memory versus immediate context. You want the model to know my name is Corn, but you don't want it to remember the exact way I phrased my question about the weather 3 days ago.
And that distinction between short-term conversation context and long-term memory is where the industry is consolidating. We're seeing a split in the architecture. You have the immediate context, the last 3 to 5 exchanges, which stay high fidelity in the prompt. Then you have the vector database, the RAG retrieval, augmented generation, which holds the long-term facts. And then you have this third layer, the session management layer, which decides what moves from the immediate context into the long-term memory and what gets deleted.
So, for the developers listening who are building these Telegram bots or custom interfaces, what's the move? If they want to avoid the mess Daniel is talking about, where do they start?
Start with explicit session tokens. Every time you send a request to your backend, include a session ID. If that ID changes, your backend knows to clear the context array before calling the AI API. Then, give the user a way to change that ID. In a Telegram bot, that's a button on an inline keyboard that says New Topic. It's not as sexy as an autonomous agent, but it's reliable and it saves you a fortune in tokens.
And what about the prompt itself? Can we use the system prompt to help the model police its own context?
You can, but it's a bit like asking a hoarder to clean their own house. You can tell the model, ignore irrelevant previous context if the user changes the subject, but the model still has to process all that irrelevant context to decide it's irrelevant. The better way is to use a gatekeeper model. A very small, fast model that looks at the new message and the previous context and just returns a true or false on whether the session should be reset. It adds maybe 50 milliseconds of latency but can save you seconds of processing time on the main model and significantly improve the logic.
It's basically a bouncer for the conversation. I like that. It feels like we're getting to a point where the front-end engineer has to be just as much of a psychologist as a coder. You have to anticipate when a human is done with a thought before the human even realizes it.
It really is. And as these models get better at reasoning, they'll start to handle more of this themselves. We're seeing research into models that can natively manage their own KV cache, that's the key value cache that stores the context, to selectively forget things. Imagine a model that, as it's generating text, is also tagging parts of its memory as low priority or expired. That would be the holy grail. No more manual session resets. The model just naturally prunes its own mind as it goes.
Until then, we're stuck with /reset and 30-minute timeouts. But honestly, even just being aware of the pollution problem puts you ahead of 90% of the people throwing together AI wrappers.
It's the difference between a toy and a tool. If you want a tool that people can rely on for hours of work, you have to manage the state. You can't just let the context window become a junk drawer.
Well, before my own context window gets too full of thermal vents and pizza, we should probably wrap this up. This has been a deep dive into the plumbing of AI, which is usually where the most interesting problems are hiding.
It's where the real engineering happens. Thanks to Daniel for the prompt, it's a challenge every dev is facing right now, whether they realize it or not.
Huge thanks to our producer, Hilbert Flemingtop, for keeping us on track. And a big thanks to Modal for providing the GPU credits that power this show and allow us to explore these technical weeds.
If you found this useful, leave us a review on your favorite podcast app. It helps other curious nerds find the show.
This has been My Weird Prompts. We'll see you in the next session, hopefully with a fresh context window. See ya. You know, Herman, I was thinking about that autonomous session management idea again. If the model can decide when to end a conversation, does that mean it could also decide to stop talking to me entirely if I get too annoying?
I think we call that a safety filter, corn. But in all seriousness, the idea of a model having the agency to say, I think we've reached a natural conclusion here, is actually a huge UI improvement. Think about how many AI interactions just kind of peter out into repetitive loops because neither the user nor the model knows how to say goodbye.
It's the Irish goodbye of the AI world. You just stop responding and hope the bot doesn't take it personally. But in a professional setting like the enterprise AI Daniel works with, that's a data hygiene issue. If you have a customer support bot that doesn't close sessions properly, you might end up with one user's data leaking into another user's context if the front end isn't strictly segmented.
That is the nightmare scenario. If you're using a shared session or a poorly managed pool of threads and you don't have a deterministic reset, you could absolutely have context spillover. It's not just about token cost or hallucinatory pirate voices, it's a fundamental security and privacy requirement. You have to be able to guarantee that when a session ends, that context is wiped from the active prompt.
So, for the devs out there, session management isn't just a performance tweak. It's a core part of your security stack. If you can't prove where a conversation ends, you can't prove where the data stops.
Precisely. Well, not precisely, I'm not allowed to say that. But you're right, the architecture of the future isn't just bigger models, it's smarter wrappers. The front end is where the battle for reliable AI is going to be won.
On that note, I'm going to go deterministically reset my brain with a nap.
A wise move, brother. Catch you later.
Later. Wait, one more thing before we actually go. We talked about LangGraph and Crew AI, but what about the really simple stuff? Like, just putting a character limit on the history. Is that too crude for 2026?
It's not too crude, but it's risky. If you just take the last 5,000 characters, you might cut off the middle of a crucial instruction. A better simple approach is a sliding window of whole messages. Always keep the system prompt. Always keep the last 4 messages, and then maybe include a summarized version of everything else. It's the middle ground that keeps the model grounded without letting it get overwhelmed.
The middle ground. The place where sloths and donkeys meet.
Something like that. Alright, for real this time, let's get out of here.
Done. See you, everyone.
Bye.
Okay, I'm looking at the word count, and we're actually a bit short. We need to go deeper. Herman, let's talk about that specific case study Daniel mentioned, the Telegram bot. If you're building a bot on Telegram, you're dealing with a platform that is inherently a single, long-running chat. There is no new chat button in the UI. How do you handle a user who uses that bot for 3 different projects over the course of a week?
That's where the concept of threads comes in. Telegram recently introduced topics within groups, but for a one-on-one bot, you're still stuck in one window. The way the pros do it is by implementing an inline menu. You know those little buttons that pop up at the bottom of a message? You should have one that is always present, or at least appears frequently, that says Start New Session. When the user clicks that, the backend generates a new UUID, a unique identifier for that session. All subsequent messages are tagged with that UUID in your database. When you pull the history to send to the AI, you only pull messages with the current UUID.
So the user stays in the same chat window, but the AI's memory is segmented behind the scenes. That's clever. It keeps the UI clean, but the context pure. But what if the user wants to go back? What if they say, hey, remember that thing we talked about yesterday? If you've segmented the sessions, the AI is going to say, I have no idea what you're talking about, Dave.
And that's where the metadata comes in. This is what we were touching on with the briefing notes. You don't just delete the old session, you index it. You can use a process called semantic search. When a user asks about a past topic, you can have a separate step where the system looks through old session summaries. If it finds a match, it can inject a small snippet of that old session into the current one. It's like the AI having a flashback. It's not the whole history, just the relevant part. This is how you balance the need for a clean context window with the user's expectation that the AI actually knows them.
It's like a filing cabinet. The AI isn't holding every piece of paper in its hands, but it knows where the cabinet is and can go grab a folder if you ask for it. This actually connects to what we discussed in episode 1279 about why AI obeys the developer instead of the user. The developer is the one who sets up these filing systems. If the developer hasn't built a good filing system, the AI is just standing there in a room full of loose paper, getting more and more confused.
That's a great way to put it. And the stakes are getting higher because as we move toward 2027 and beyond, these context windows are only going to get bigger. But a bigger window doesn't mean a better brain. In fact, it often means more noise. We're seeing research that suggests that even with a million token window, models perform better when they are given a curated, smaller context. It's about the signal to noise ratio. If you give a model 100 pages of text but only 5 sentences are relevant to the current task, the model's reasoning can get bogged down in the 99 pages of fluff.
It's the paradox of choice. But for data, just because you can give the model everything doesn't mean you should. I think that's the big takeaway for me today. Good engineering is often about what you leave out, not what you put in.
Efficiency is elegance. And in the world of AI APIs, efficiency is also accuracy. If you look at the best performing AI agents right now, they aren't the ones with the biggest prompts. They're the ones with the most precise prompts. They use tools to fetch only the data they need at the exact moment they need it. This is why things like function calling and tool use are so important. Instead of giving the model a huge table of data, you give it a tool to query that table. The result of the query is the only thing that goes into the context window.
So, instead of the model being an expert who has memorized every book in the library, it's an expert who is really good at using the library's search computer.
And that search computer, that front-end logic, is what the engineer has to build. It's about creating a system where the model is always working with the freshest, most relevant information. Daniel's point about stateless APIs is so key here. The API is just a mirror. It reflects back whatever you show it. If you show it a mess, you get a messy answer. If you show it a clean, focused session, you get a clean, focused answer.
I'm thinking about the user experience side of this too. If I'm using a bot and it suddenly loses my context because of a session reset I didn't ask for, that's a bad experience. But if it keeps my context for too long and starts making mistakes, that's also a bad experience. There's a sweet spot there that we haven't quite standardized yet. Do you think we'll see a standard protocol for session management? Like a way for the user's client to tell the AI, this is a new thread, and have that be understood across different models?
We're starting to see it with things like the Model Context Protocol, or MCP, which Anthropic has been pushing. It's a way to standardize how models interact with external data and tools. I wouldn't be surprised if we see a similar standard for session and state management. Imagine a header in the API call that just says Session Strategy, Autonomous or Session Strategy, Periodic Summary. That would take the burden off the developer and let the model provider handle the heavy lifting of context optimization.
That sounds like a dream. But until that day comes, we're the ones who have to build the bouncers and the filing cabinets. It's a lot of work, but it's what separates the hobbyists from the pros. I feel like we've really cracked this open today.
It's a deep topic, and we've only scratched the surface of the architectural possibilities. But the fundamental principle remains: manage your context, or it will manage you.
And usually, it'll manage you right into a hallucination about pirates.
Or pizza toppings.
Or pizza-eating pirates. Anyway, I think we've hit our stride here. Let's actually wrap it up this time before I start talking about deep-sea vents again.
Good call. Thanks again to Daniel, and thanks to everyone for listening.
This has been My Weird Prompts. We're on Telegram if you want to get notified about new episodes. Just search for us there.
And check out the website at myweirdprompts.com for all the back episodes and RSS feeds.
All right, Herman. Let's go find some fresh context.
See you later, Corn.
Bye. You know, I was just thinking, we mentioned the cost implications, but what about the environmental impact? If every AI request is 10 times larger than it needs to be because of poor session management, that's a lot of extra electricity being used to process useless tokens.
That is a very real factor. The energy required to run a forward pass on a large language model is proportional to the number of input tokens. If the world's developers all optimize their session management and cut their average prompt size by 30%, that would be a massive reduction in the carbon footprint of AI. It's another reason why this isn't just a technical niche. It's a global efficiency issue.
So, session management is basically recycling for nerds. I can get behind that.
It really is. It's about being a good steward of the compute resources we have. We should treat tokens like a precious resource, not a cheap commodity.
Spoken like a true donkey, always looking for the most efficient way to carry the load.
And spoken like a true sloth, always looking for the way that requires the least amount of unnecessary work.
Hey, efficiency is my middle name. Corn Efficiency Sloth. Has a nice ring to it, doesn't it?
It really doesn't, but I'll let you have it.
Thanks, Herman. Alright, let's get out of here for real. My battery is at 5% and I don't want to start a new session.
Understood. Closing session now.
Goodbye.
Bye.
Wait, I just realized we didn't talk about the context window pollution in the context of multi-model agents, like what we discussed in episode 1858. If you have one model doing the session management and another doing the actual work, doesn't that create a whole new set of handoff problems?
It absolutely does. That's the instruction and context gap. If the management model decides to start a new session but doesn't pass the right instructions to the worker model, the whole system collapses. You need a unified instruction set that persists across session resets. This is why the system prompt, the developer's instructions, is the most important piece of real estate in the context window. It has to be bulletproof.
It's the constitution of the conversation. The laws that don't change even when the session does.
You have the permanent laws, and then you have the temporary session data. Keeping those two things strictly separated in your code is the secret to building stable AI agents.
Okay, now I'm actually done. My brain is officially full.
I believe you this time. See you later.
Later. Just checking the word count one last time, and we are right in the sweet spot. Daniel, I hope this gave you and the other devs out there some solid ideas for your next project.
It's a journey, and we're all learning as we go. But focus on that session management. It's the key to the next level of AI utility.
Totally. All right, for the 10th and final time, goodbye.
Bye.
Herman, I just had a thought about the loss in the middle problem you mentioned earlier. If developers are struggling with session management, couldn't they just use models with smaller context windows to force themselves to be more efficient? Like, instead of using a 128K model, use an 8K1.
That's actually a brilliant, if somewhat masochistic, engineering constraint. It's like learning to code on a computer with very little RAM. It forces you to be incredibly clever with how you manage your data. If you only have 8,000 tokens to work with, you can't afford to be lazy. You have to summarize, you have to prioritize, and you have to reset sessions aggressively. It's a great way to build the discipline needed for high-quality AI engineering.
It's like training with weights on. Then, when you switch back to the big models, your session management is so tight that the AI performs like a genius because it's getting nothing but pure, high-density signal.
I love that analogy. Well, it's not an analogy, it's a strategy. It's a way to ensure that you aren't just relying on the model's brute force memory to cover up for poor front-end architecture.
I might try that with my next bot. Build it for a tiny window first, then scale it up. It's the sloth way. Do the hard thinking once, so you can be lazy later.
It's the only way to build something that actually lasts.
I'm thinking about a specific scenario Daniel might face. Let's say he's building a technical support bot for a software suite. The user keeps asking about different modules. If the bot keeps the context of module A, while the user is now asking about module B, it might try to apply the troubleshooting steps for A to B. That's where the gatekeeper model you mentioned earlier becomes vital. It needs to recognize the shift in technical scope.
In a technical context, the cost of pollution is not just a weird joke, it's a wrong answer that could lead to data loss or system failure. You could use a RAG-based approach where the gatekeeper identifies the active module and swaps out the entire documentation set in the context window. That's session management at the object level.
It's like a surgical swap. Out with the old DLLs, in with the new ones. It makes the model feel much more responsive and present.
And that's exactly what users want. They want the AI to be smart enough to know when to let go.
All right, I'm satisfied. We've covered the technical, the practical, the environmental, and even the masochistic sides of session management. We've looked at the UI hurdles of Telegram and the invisible walls of stateless APIs.
We've done it all. It's about building a bridge between the jumping, nonlinear way humans think and the linear, token-hungry way these models process.
Last thing, I promise. We should mention the human side. Sometimes users want the pollution. They like it when the AI remembers their weird tangents because it feels more human. How do we balance that?
That's where user-controlled state comes in. Give them a pin this button for certain facts. If they pin a fact, it gets stored in a persistent user profile and stays in the system prompt forever, even through resets. Everything else gets wiped. It gives the user the power to decide what's baggage and what's a keepsake. It turns a limitation into a feature.
A keepsake button. I love it. It's like a scrapbook for your AI interactions. Okay, now we're really done.
Goodbye, everyone.
Bye. This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show. My weird prompts where our thoughts go from slow takes to facts on cue. We change and